Thank you, everyone. Have a good afternoon. My name is Peter. I'm going to talk to you about InterPlugin Communication today, breaking out of the channel strip, our take on such a topic as a plugin manufacturer, and maybe give a little bit of inspiration for you if you want to approach this topic on your own. So what's to be expected today? I'm going to talk a little bit about the who did that, because without the who it doesn't make too much sense. A little bit about the why, the actual what and how. And in the end, I'm going to talk about the limitations, because there's no free lunch. We all have to struggle with, the world we're living in as plugins. So the who, that's going to be a quick one. We're Sonible. We're a plugin manufacturer company based in Graz, Austria. And what we do is we build smart plugins. We build a smart equalizer, a smart compressor, a smart limiter, a smart de-esser, a smart gate, a lot of smart standard processing blocks. And what all of them have in common besides the smartness is that they are just plugins in a channel strip. And a channel strip implies a bit of loneliness. So everything you know about the world outside is very, very limited. You got only the samples you receive for processing. You're not supposed to know any more of that. You don't really know, am I alone? Is there anyone else around? Or what possibly could they be doing? So in terms of smartness, that's not so smart. That brings me to the point, I need to start my timer, sorry. Why would we even do that? Apparently, a mix is much more than the sum of its components. I think that's quite a natural thing to say. The actual art of mixing comes with a lot of experience and the capability of observing content across a multitude of channels at once and drawing conclusions from those observations. So channel strip isolation in that regard is really not beneficial, because what's happening in my channel might be completely contradictory to what's happening on another channel. So thus it's really a thing to aim for, to get knowledge of what other channels are filled with, basically. And that kind of also prevents making smart decisions in the beginning, because imagine a very simple case of a real-time analyzer. You got two tracks that might be somewhat competing in terms of spectral distribution, frequency masking, and so on. What would you do? You'd throw one analyzer instance of each of those channels, have both windows open at the same time, and you'd very quickly realize that it's quite hard to grasp what actually frequency and value X, Y positions match up. So wouldn't it be much, much, much easier if we had a way to just sum those different channel information up in one single view? So that's a very trivial thing actually to do. We got one window open, we collect spectra from different channels, display them in the same window. Levels are aligned perfect. It's much easier to identify clashing frequency regions. So yeah, that's easy. That brings me to the next point, immediately spectral mixing. So if you consider clashing frequency, what you would typically do is retain certain or remove certain frequency regions in specific tracks. But that also implies that you need to be aware of what the content of the track is. It doesn't only suffice to have a momentary look at it. You need to have a large observation and see what's going on, because that's what the engineer would typically do. They would solo the one track, here listen to it, solo the other track, and then draw conclusions manually in an EQ. That is just exemplary. I wouldn't EQ like that at all. So depending on the source type, that's one key aspect to it. A guitar and a vocal recording don't share the same interesting or important frequency areas. So this is something we need to consider. And the actual signal, because not every guitar, not every vocal has the same spectral distribution. That's a lot to do manually, and it would be very nice if some tool could do that for you. Well, in that case, we do need spectral InterPlugin Communication. Another more exotic application would be depth. Depth is a function of a proportion of direct sound, early reflection, tail, blah, blah, spread across multiple channels. And you need to employ that by knowing what channel does what and so on. So also in this case, information about the other channel contents is of the essence. How do we get to that information? Apparently the answer to this question is InterPlugin Communication. What is InterPlugin Communication? We have come up with a definition that basically says it enables a plugin instance to A, discover other plugin instances of any kind, basically. B, it allows for opening communication channels. So it should be able to either request data from another instance or push data to another instance. And that is more application motivated. It should be capable of building logical groups. I don't want every single instance within a mix, say of an EQ, to be in the same group. I want to say, okay, this is my guitar sub-bass, this is my backing vocals, this is my drum kit, whatever. So the two basic components of InterPlugin Communication, the way we perceive it, is service discovery. Service discovery meaning a way to advertise to the world, I am here, I am willing to interact with you, get in touch. So this is a one-to-many broadcast situation. On the other side, we have a communication channel that's required. There's different approaches to that, depending on how far you want to communicate, let's say it that way. I'll get to that later on. But normally this is a one-to-one bidirectional connection. It should be agnostic of the actual data that's being transmitted, and it may or may not add authentication, encryption, and so on. But this is a detail that I don't want to get into. So, what forms, what is the representation of a mix in that sense? We consider every plugin instance an entity or node. Every single of these nodes, and we can actually create a separate entity for a view and a processor that can come in later, quite handy. That one advertises its identity, its existence. It regularly updates every other instance around about that. It advertises the means of communication that we can use to interact with that entity, and it also advertises its group affiliations. So all of these instances, we refer to them as the swarm. They're all made of this, basically implementing the same interface, and every node keeps a register of all of the other nodes around, and their group affiliations and the means of communication. So what we need to do when we're establishing groups is, groups are a subset of the swarm, and instances of that kind share certain properties, common properties, like for instance a group membership and a group name and so on. And to some extent it comes in handy when a group has a group leader, because not every aspect of the processing needs to be done by everyone. We can save a lot of resources if we concentrate that on a single instance, on a single node. Thus our service discovery implements a way of electing a leader within a group. The leader then is responsible for setting group properties, for instance, like the group name that's supposed to be displayed to the user, the group color, whatever. So you might ask, why not just have a central hub that does all of that for you? Yeah, that's a very valid point. The problem is, or not the problem, it makes a lot of stuff easier because it is the single source of truth. It is the central point of transfer. Also, you can route any kind of communications through that broker instance, but it's a single point of failure as well. So it's crucial to have a very, very close eye on lifetime management of a set instance, because if it passes away and there's no way to recover it, you get into big trouble. This is why we have decided to go down the other way. We built our service discovery as a distributed system, so there is no broker, there's no God instance. Everyone can basically fill in for everything. There's, on the other hand, no absolute truth. So nodes must agree on the truth, and this needs to be done by implementing a decision-making mechanism. And you need to have a certain quorum. You need to be sure that, sorry, that a majority is qualified. Yeah, but this we can talk about a little bit later. And the upside is if one of the nodes disappears, be it by the user just removing it from the channel, it may be just maybe by coincidence the leader instance that was removed, the group would decide to elect a new leader, and that would just fill in for that very purpose. So, how did we do that? InterPlugin Communication implementation detail depends very much on the scope. And by scope, I mean, how far do I want to communicate? If it's just beyond instance boundaries, being 35 instances of the same EQ, hence same shared library object in memory, that's easy in comparison. Imagine an equalizer on kick and bass. Yeah, makes sense. Beyond process boundaries, it gets a little bit more complicated, but it makes a lot of sense because some DAWs already implement sandboxed plugin hosting processes. If I want to communicate across those boundaries, I need some more sophisticated way to do it. The last scope I'm mentioning here is beyond machine boundaries, really meaning my MacBook is going to communicate with some MacBook back there. They're sharing information. It might be relevant for practical use, I don't know, but it's technically possible, and it shall be mentioned here as well, because we never know what the future might bring. So what kind of communication stack do we want to choose? There's also multiple viewpoints to that. Static memory, easy. Just create a singleton class, have it register, unregisters instances once they come to life, and have that singleton instance do all the messaging for you. That's relatively easy to do. More complicated is it when using local sockets. Local sockets are available on actually all of the desktop operating systems around. It's quite easy to do. There is a lot of very well-documented, very performant libraries to do that. It's a nice thing to do. And last but not least, IP. So clearly, when we want to go beyond machine boundaries, we need to use full networking stack with the implications on latency and bandwidth. Because apparently, when we're in memory, it's much easier and way less overhead sending larger messages compared to a IP with all the fragmenting and stuff going on. On the other hand, IP has the largest scope, whereas static memory is only applicable to the beyond instance case, and that's where we end up. So basically, we decide on an application basis, what scope do we need, and use that kind of technology from that we have. So what does building a service discovery actually mean? In our case, we said, okay, service discovery itself, I just want to inform as many people, as many instances as possible about the existence of us. This is why we're using the IP stack here. And actually, we're using UDP beacon. So we have an instance, like every plugin instance or every view instance and processor instance would bind to a local port and broadcast or unicast on that interface, loopback interface, or just local area network interface. We needed to define a protocol, and that's actually the key to it. So that protocol needs to carry all the information that we want to provide to the rest of the swarm, that being identification, some unique ID. What IP am I on? What's my name? What's my type? What's my product? What's my bundle ID? What's the process I'm being hosted in? What's the endpoints that I'm exposing, meaning what kind of communication layer is implemented? What groups am I in? What groups do I lead? And so on. That's part of every message basically we're sending out through the UDP beacon, and that all the other nodes are keeping a register of. So for this to happen, we need a predefined set of messages. So you can imagine a new instance is coming to life, being created by the user by dragging it into the channel strip, and would just say, hello, sending its identity, and everyone in the swarm would respond to that by welcome and adding an entry to the register. Likewise, when the instance disappears, it would send a bye, and everyone would be aware of this. Now, in the case that something goes sideways and there is no legitimate goodbye, we need to send a ping, like every few seconds or 100 milliseconds, just to keep the swarm updated that I'm still here and I'm okay. If there is no ping coming, at some point the swarm would assume the instance is dead, and if it was the leader, it needs to start an election and so on. Hence the elected leader messages, those are very specific to the grouping mechanism. And we also need to add an arbitrary set of properties to that protocol. So we have the identification header, then we've got message type, and then we've got a arbitrary set of data. So if, for instance, a display name that is supposed to be the tracker name in the DAW, that wouldn't go into the protocol. It would just be a property that's been able to be set by the application. Also, what we need to do is employ a filter, because we certainly don't want to communicate with every instance around of every plugin type in every process. Because, for instance, imagine a situation where the user would have a Pro Tools session and a Logic session open with the same plugins in there. I definitely don't want to mix up my Pro Tools EQs with my Logic EQs. So that kind of low-level filtering must be there. And for grouping and leadership, where basically every instance should be able to join or create or join a group, we need to make sure that the group leader, as I said before, can be elected stably. There's approaches in literature, one of them which has proven very stable and relatively easy to implement is the pulley algorithm that yields a stable election result given a stable majority. Because if you don't do that correctly, you can run into split brain situations where one half of the swarm doesn't believe the other half, and then things start to get really messy. Yeah, and in our case, we defined that the group leader is the one that decides on group properties, such as a group name that needs to be populated across the entire swarm, group color or whatever. This is really purely application driven. Then, building a comm channel, that is the fun part. The scope in that case is much more limited. So we don't really care about messaging through machine boundaries. We just want to stay either in static memory if the application allows for it, or we want to do the local sockets. There is 2 libraries I can really recommend you to have a look into, also in terms of documentation, because there's a really good read. The Sciri MQ that's been around for quite a while, and NanoMessage and its successor NanoMessage Next Gen NNG, and its C++ binding NNG PP. Those are really well maintained, well documented, and all of these open just raw data interfaces. Many of them even asynchronous raw data interfaces, so you could just drop in a bunch of data, and you could rely on the underlying threading mechanism to take care of the delivery of those datagrams. Then what we also needed to do is settle on a transmission scheme. So you could do remote procedure calls. In most cases, it's just okay to do it HTTP style, like post something from A to B, get something from B to A. That is very sufficient. And a last consideration to make is about payload size. In static memory, obviously, it's simple. You can just get the instance, call into it, give it the data it's supposed to have. If you're going through some kind of raw data interface, you need to serialize the data. And on that behalf, we have made very good experience with protobuf, which is maintained by Google, or Captain Proto, which is a very lightweight alternative to that. Also very actively maintained. You can ask the authors, they would answer within a glimpse of an eye. So that's a very efficient and convenient way to get from an abstract big data structure to your serialized data and back to it in another instance. If you're interested in that and how to establish a framework that allows for connecting to those endpoints to have an abstract way of deciding, okay, do we want to do this in memory? Do we want to do this on a network stack? I can highly recommend you visiting my colleague Janus's talk tomorrow at 3 in Room Empire. He's got a 50-minute slot. 90 would be plenty, to go really into detail about that and how we manage to integrate that in our products. So I have got a few minutes left before going to the limitations. I'm going to quickly show you what all of this, what we just did, means in the product. I've added a screenshot, but I think it's just fancier if I do it like this. So this is just a dummy testing session. Don't take any of this seriously. But what you can see is I have got a larger number of SmartEQ 4 instances, which is one of our most recent product releases on the tracks. And you can see those instances being displayed here as well. So apparently everyone knows who's around. And what I can do is you can see, I don't know if you can see the contrast is not really, and actually it's not even moving. It's moving on my screen, sorry for that. Oh, no, sorry, I need to stop this and switch. All right, sorry for that. Haven't done the PowerPoint in a while. So what you can see here is multiple instances of SmartEQ 4. You can see analyzers that are being sent through data channels. That's the nice part. What you can also do is you can see properties assigned within the group. So the group is called group. You can move those instances around, and what you can see, like this is now from a product perspective, what this does is spectral mixing for you. You can see the backing vocal track here on the front layer. These are 3 layers. It's hard to identify. It's the front layer, the middle layer, and the back layer. And if I move the backing vocal from the first layer to the bottom layer, you could see how the spectral shape is changed by the group impact. We call it that way. And what's also possible, besides sending instructions to plugin instances and retrieving, in that case, analyzer and parameter states, we can just add remote control like that. So if I add a filter, this is the wrong instance, sorry. If I add a filter here, you can just see it magically moving around in the other instance, which is, again, completely separated by the DAWs channel strip isolation. Yeah, so we're really happy with that. But as I said before, how do we get play from current slide? What are the limitations? Well, the most outstanding limitation is no audio, sorry. We can do control data, we can do anything that's not time critical. Why? Because synchronicity isn't given. So the DAW can at any point decide to process one channel at once, the second afterwards, do interleaving, whatever. We don't know anything about that. So we cannot assume that if one channel instance receives enough data to, I know, draw an analyzer curve, the other instance might be seconds behind. Another thing we don't know anything about is latency compensation. So again, this is purely the decision of the host. We don't know anything about it. We cannot assume anything about it. Also, transmission delay when we're using some kind of packaging technology. Transmission delay gets really unpredictable in an offline case, what might take a millisecond or a bit more in real-time rendering and is negligible hence, might have a way larger representation in offline rendering because things are just moving much faster. So this is also something we cannot use. That's why all of these features that I just showed you are not automatable, because we don't want users to do that in offline rendering, like the group membership and layer property and so on. And also, apparently, we can't do anything sample accurately. Sidechain input needs to be routed still. This is also due to the host deciding when and what kind of data to send. And the second really inconvenient thing for us still is we don't know anything about the processing graph. We know that there is 35 SmartEQ 4 instances. We don't know anything about any other plugins in the processing chain. We don't know anything about penning, nor about the fader position level in the mix, routing whatsoever. So this basically means that in the end, we must rely on the user to be smart enough to don't change too much, because otherwise our proposal would not be valid anymore. That's quite a big limitation for us, also from a product perspective. And this leads me to a request, a Christmas wish list, actually. Dear DAW developers, life would be so much easier if we could just, in some way, standardize, on the one hand, accessing the processing graph detail. So like, what channels are there, what plugins are there, in which order are they, what's the channel level, penning, and so on. And on the other hand, means of establishing communication channels. We can do this using sockets, we can find our solutions, we will, apparently, because product management says so. But it would be much easier and more secure and better maintainable if there were a standardized way to request a communication channel from the DAW. That's it. Thank you very much for your attention. I hope you enjoyed it and open for questions.